Before we can explore why alcohol makes your head think it's spinning when it's really not, let's first establish how your head can tell that it's rotating under normal circumstances. Within your inner ear, there are little tiny fluid-filled structures called semicircular canals. You can essentially think of them as very thin inner tubes with an enlarged bump on one side. Inside of this bump is a gelatinous structure called the cupula, which spans the inside of the tube. And embedded in this gelatinous structure are what are called hair cells. These are called hair cells because they have what appear to be little tiny tufts of hair sticking out of the top of them. When these little hair-like structures get bent to one side, the hair cell sends signals to your brain. So the point of the structure of the semicircular canal is to transform a rotational energy into a force which can bend these little hair-like structures and then be noticed by your brain. What happens is, as you start to rotate your head, the fluid inside these canals lags behind. This is the same idea as if you were holding a pan full of water in front of you and suddenly began to walk forwards. Due to inertia, the water would want to stay where it was before you started to move, and so it would slosh back towards you. In the same way, the liquid inside these little canals does not want to move. And so as the structure starts to rotate, a pressure forces the cupula out of shape and bends the hair cells. Of course, if you only had one of these structures in your head, you could only notice rotations along one axis. And so what has evolved is a system of 3 semicircular canals per ear, so 6 total. And each ear has one along each axis. They're 90 degrees towards each other. So there's one that looks kind of like a hula hoop would if you were using it, one like hoop earrings, and one like the circle around the Vitruvian Man. And these allow your ear to tell when you're nodding, doing a cartwheel, or spinning around in an office chair. With all of these sensors combined, your head is now sensitive to rotations in any direction in 3-dimensional space. Now, as an interesting side note, you may notice that this system is based on the lag between the fluid and the canal structure itself. So if you were to spin at a constant rate in the same axis for a long period of time, eventually the fluid would catch up with the structure and the hair cells would stop responding. Now, this isn't usually a problem in everyday life since you don't usually spin exactly the same way for at least 30 seconds, which it turns out is how long it takes for this to happen. But it's actually an issue for pilots, who can take these sorts of controlled, consistent turns for long periods of time pretty regularly. And if they do these turns for long enough, eventually their inner ear gets used to it and they stop responding. So when they go to straighten the plane out, then suddenly the fluid wants to keep going because now it has inertia that's rotating the way the plane was a second ago. And so this causes an illusion where it seems like the plane is now turning the opposite direction than it was originally turning. Now this is a serious problem because if the pilot believes this hallucination, which can be pretty convincing, then they'll want to turn the plane back into the original curve, which they will now perceive as going perfectly straight. This is referred to as a graveyard spiral and can lead to planes spinning around and around until they eventually crash. It's claimed many lives in conditions of poor visibility where it's difficult to use other senses to make up for your wonky vestibular system. So back to alcohol. How does alcohol interfere with this system? Well, it turns out that alcohol diffuses into different parts of your body at different speeds. So as you're drinking, the alcohol starts to build up more quickly inside the gelatinous cupula structure than it does inside the actual fluid inside the canal. It does eventually get into the fluid, but this transition takes a while. So for a period of time, say 3 to 5 hours after you're drinking, there's a density gradient. So that the cupula, which is normally the same exact density as the fluid in the canal, is now slightly lighter since alcohol is lighter than water. So this means that the cupula wants to float. Now this is obviously a problem because your semicircular canals are now sensitive to gravity, which they should not be. So if you tilt your head to the side, say you're lying on your left side of your face, now one of your semicircular canals is oriented such that the cupula wants to float. And as it wants to float, it's bending itself upwards and giving your brain the illusion that you're starting to accelerate, that you're rotating towards your left side. And since this sensation is constant, it feels like you're going faster and faster and faster. And this is the sort of dizziness that you get when you try to lie down after drinking too much. Now, as time goes on, the alcohol does diffuse into the liquid in the canals, and there's a quiet period where the densities in the cupula and the canal fluid are the same. And this means that you're no longer sensitive to gravity, and they operate normally. Unfortunately, as more time passes, the same process happens in reverse, because the alcohol leaves the cupula more quickly than it leaves the fluid inside your canal. And so this means that now you're rotating the opposite direction, so if you were leaning on the left side of your face, you'll now feel like you're spinning to your right. This effect is generally less strong, but it's a significant portion of what people associate with having a hangover. Interestingly, this kind of validates the idea that having a small drink the morning after can help you get over some of the effects of a hangover. What this would do is raise the amount of alcohol in your cupula and temporarily stabilize their relative densities. Of course, this is really only delaying the problem since eventually it'll drain out again and the whole process will start over. Experiments have shown that you can disturb the functioning of the inner ear by ingesting all sorts of different substances that can dissolve in water but have a different density than water itself. An example of this is heavy water, which is water with a high amount of deuterium in it. Deuterium is an isotope of hydrogen, which is 11% denser than normal hydrogen. So functionally what you have is a substance which is very similar to water, but heavier. So if you drink some of this stuff, which please don't try this at home because it is toxic in high amounts, but if you were to drink some of this, it would temporarily make your cupula more dense than the fluid inside your canals, and you get the opposite spinning direction that you do from alcohol. So in theory, and again I have to stress, please don't try this at home, is you can drink some heavy water to counteract the effects of alcohol, and then you would have less dizziness from your drinking. Of course, a much safer way to deal with alcohol-related dizziness is just to rely on your other senses to help sort out what's going on. In everyday life, your brain relies pretty heavily on your vision and muscular feedback to tell if you're balancing properly. So there's anecdotal evidence that it helps a lot to keep your eyes open and look at something that's not moving, and maybe even put a foot on the ground so that your brain has a good, solid foundation for figuring out where it is in space, and you won't get so confused, and hopefully you won't feel as nauseous. Thanks for watching Explaincast. If you enjoyed it, please rate and subscribe, and feel free to send me suggestions for future episodes at twitter.com/explaincast.